Science Center. Welcome to our Friday night Sky This Month program. Now, ordinarily, we would be doing this from the Chabot Space and Science Center, and I'd be in one of the venues up there showing off a little bit about our exhibits. However, as those of you in the Bay Area know, it is blazing hot in the Bay Area right now. And I was looking at the temperature up at Chabot. It was actually hotter at 6 o'clock this evening than it was at 3 o'clock this afternoon. So it is really hot up there. And because Chabot is right now operating under a limited mode with no public entry at this time, waiting for our grand reopening next June, we don't have the air conditioning on up there. So it is really warm inside the facility. So I'm doing this from my living room today. So I hope you don't mind. I hope everybody had a chance to get out and maybe try to see the meteor shower a couple of nights ago, Tuesday night, early Wednesday morning, the Perseid meteor shower. This year, it was not the most spectacular meteor shower. There were only a few to be seen. I had to stay up until 2:30 in the morning before I finally saw one. So bit of a disappointment, but it happens every year. So come back next year and we'll try it again. A couple of announcements I wanted to do here. Chabot right now is doing a fundraising campaign. It's an auction, and it's a chance for you to bid on some really exciting photographs and some exciting activities. We have a number of moon prints of the moon taken by astronauts, taken by spacecraft, even some taken by Chabot's telescopes. These were all large prints that were made for the Luminous Moon exhibit that we did last year in celebration of the 50th anniversary of the Apollo landing. And those are now being auctioned off. In addition, we also have a number of experiences like a dinner under the stars and a private session in the observatories and so forth that you can bid on as well. So this is an auction that's going to be going on for the entire month of August. And we're going to post a link in the chat section for you to use to go to that page if you'd like to bid on one of the items. You'll see two categories. One is for the experiences and the other is for the Luminous Moon photographs. Check them out. Maybe you'll see something there that you like and you can bid on them and hopefully you'll get them. Also, even if you don't want to support us by doing the auction, you can always support us by clicking that donate button that you see just above the chat section in the Facebook page, or you can go to Chabot's website, chabotspace.org. And up at the top of the page, you'll see a donate button. Click on that, and we'd love to get your support to keep us going until next June. We're going to continue to do live programming like this online, occasional small events later on this year, and we'll just keep whatever activity we can keep going, and all of that will be in preparation for our grand reopening next June. So check that out. A couple other things I wanted to call your attention to. This coming Wednesday, next week, Wednesday, at 8 o'clock on Chabot's Facebook page, there's going to be a presentation. If you are interested at all in the history of the Chabot Space and Science Center, it's a 137-year history. Ben Barres, who is our content developer and also one of our staff astronomers, he is going to be doing a presentation about Chabot's history. And it's a really great presentation. He covers a lot of details that most people, in fact, a lot of employees and volunteers at Chabot didn't know about. So it's a really great program. And I would encourage you to check that out. That's 8 o'clock Pacific time next Wednesday. Also, a week from today, we have a very special event going on. Some of you may be aware that Chabot has been at the Skyline Boulevard site in the Oakland Hills for 20 years now. And in fact, this is our 20th anniversary coming up. It opened, our grand opening was in August of the year 2000. And so we're going to have a special event a week from tonight, kind of a mashup of all kinds of different activities, stories, and photographs, and so on about the history of Chabot and personal reflections about different people's experiences with Chabot. It should be a really great program. And again, that'll be at 8 o'clock on Friday night, a week from tonight. And you definitely want to check that out. So before I continue with our regularly scheduled program tonight, I did want to acknowledge a couple of people who you never get to see, but who are really important. We've been doing these virtual programming now for several months, and it looks probably pretty simple to you out there on Facebook land, but it actually takes a lot of work to coordinate these, to schedule them, to plan them, to resolve all the technical issues that come up. And there are a couple of people that I want to acknowledge who really are key to doing that. You never get to see them, but I want to mention them tonight. One of them is Jessica Williams, who is actually with us right now, disguised as Chabot Space and Science Center. So when you see posts on the Facebook page from Chabot Space and Science Center, that's actually Jessica Williams. And Jessica is the one that sets up all these Facebook programs, takes care of all the technical stuff. I personally hate computers, so I just struggle with them all the time. So Jessica is the one who gets it all set up, makes it work, and does it all behind the scenes. You never get to see her, but I hope if you get a chance, you might just want to say thank you to Jessica Williams. The other person is Mary Catherine France. Mary Catherine is our PR person. She also does our website, and she schedules all these events and helps us also with all the technical issues. She's probably the most expert as far as making things work on Facebook. And she's not even in the state of California right now. She's up, I believe, in Washington right now, but she often watches to make sure everything goes right. So between Jessica and Mary Catherine, this all works. And I am really grateful to them for helping out. And I hope you get a chance to just send them a thank you, if you don't mind. So with that, tonight our program is about the sky this month. And Don Saito is an EAS member and a longtime Chabot volunteer. And he produces and directs and writes and sometimes narrates these programs. So we've got one tonight. This one will be narrated by Barbara Sams, who is also an EAS member. EAS stands for East Bay Astronomical Society, which is the amateur astronomy club that's based at Chabot. And so they've put together a nice little video that we can watch to see what's up in the sky tonight. So bear with me for a second while I get that all set up. And here we go.
Hey there, everybody. Just because current conditions are such that we can't meet inside our amazing Zeiss Planetarium at Chabot Space and Science Center doesn't mean we can't go outside and look up the real sky ourselves. This short presentation will help guide you to find several bright stars, constellations, and planets. For the month of August, from about 9:30 to 10 p.m., we are well into the summer season of constellations, and it's these I'll be pointing out. Why the late hours, you might ask? It's because during the Northern Hemisphere's summer season, the days are longer and the nights are shorter. That, plus daylight savings time, means late starts for us night sky watchers. By the way, if you weren't already aware, yes, the constellations have seasons. For example, you'll never see Taurus, the bull, during the summer. And likewise, you'll never see Hercules, the strongman, in the winter. We'll meet Hercules in just a bit. As you probably already know, the Earth has 4 seasons: spring, summer, fall, and winter. Well, the constellations also have seasons, having to do with the Earth's orbital path around the Sun. That and the fact that we can only see stars by looking away from the Sun at night, which changes our view of the stars throughout the year. Unfortunately, unless you're at a good dark sky site, most constellations will be somewhat hard to see fully, but most constellations have at least a few bright stars to help identify them, and the better your viewing location, the more you'll be able to see. A good first step to finding the constellations is done by knowing your compass direction. We can easily do this without a compass using a star grouping that almost everyone is familiar with, the Big Dipper. First, find the dipper with its curving handle and bowl up and a bit to the right of where the sun set. The 2 stars at the end of the bowl are called the pointers, because if you take the distance between them and extend that distance out about 5 times, you'll come to a semi-bright star known as Polaris, and otherwise known as the North Star. It's the only star in the entire sky that stays pretty much right where it is, so no matter what time of night it is, or even what month of the year it is, all you need to do is face it, and you'll always be facing due north, with east directly to your right, west directly to your left, and south directly behind you. All of the other stars wheel around this pivot point, anti-clockwise, making them appear to rise in the east and set in the west. This is, of course, an illusion caused by the Earth's spin, which gives the appearance that the stars are moving when, in fact, it is the Earth that is moving. If you think of the Earth as a spinning top and you extend the Earth's North Pole straight up into the sky, it points almost directly at Polaris. I should also point out that the Big Dipper is not a constellation. It's only part of the constellation Ursa Major, the Great Bear. He's already partially set, so I won't describe him fully here, but at the end of the Big Dipper's handle is the tip of his nose, and the bowl is like a saddle on his back. The Big Dipper is what is called an asterism, which is defined as a familiar star grouping. Using Polaris, we found all the compass directions, but Polaris is also at the end of the Little Dipper's handle, whose official name is Ursa Minor, the Little Bear, and our next constellation. It's a bit faint, but from Polaris you might be able to trace its curving handle to its bowl. The 2 brighter stars at the end of its bowl are called the Guardians, because they seem to march around the North Star like protective sentries throughout the night. Here is Draco the Dragon, with his squarish head, long neck, 2 short legs and feet, and long tail which arcs gracefully over the Little Dipper. Rising in the north-northeast, we have a lesser-known pole-finding constellation, Cassiopeia the Queen, also known as the Big W, made up of these 5 fairly bright stars. We can also use Cassiopeia to find the North Star by using a fainter 6th star off the tip of the more squashed in of the W. This is particularly useful because it's almost opposite the Big Dipper's pointing stars, which generally aren't visible for several months of the year, depending on your latitude. So when the Dipper is down, Cassiopeia is up. Thus we can find the North Star no matter what the season. We use the pointers in the Big Dipper's bowl to find Polaris and the Little Dipper. Now let's use the Big Dipper's curving handle to find our next constellation. Simply follow the arc of the Dipper's handle in a continuing arcing line to find the bright star Arcturus, which is in the lap of Bootes, the herdsman. In other words, follow the arc to Arcturus. From our view looking due north, he's facing down, but he's got a flat triangular cap, a large head, a triangular body that appears to be in a sitting position, his leg and foot, and his smoking pipe, a simple shepherd, keeping watch over his flock. To continue, let's turn our view to the south, like so. This will flip everything we've seen to the north upside down and will enable us to find the rest of the night's major constellations more easily. Our next constellation is a small but pretty Corona Borealis, the Northern Crown. It can be found just behind the head of Boötes, the herdsman, whom we just met. The semi-bright star in its center is called Gemma. The open end of the Northern Crown points towards the squarish head of our next constellation, Hercules, the strong man. That square is the asterism called the keystone, and from there you might be able to make out the rest of him. A man running along whilst brandishing a large club, an activity typical of a strong man back in the day, apparently. Found just behind Hercules is Lyra, the lyre, a small Greek harp marked with the sixth brightest star out in the entire sky, Vega. Next up, we see Cygnus, the Swan, with his bright star Deneb, wings, feet, long neck, and nose. Just below Cygnus, we have the constellation Aquila, the eagle. He's a bit faint, but has a head with a beak and its bright eye, Altair, two swept forward wings, a body, and a tail. The three bright stars, Vega, Altair, and Deneb, make up the asterism we call the summer triangle. We'll be seeing the summer triangle through summer and well into fall. Riding somewhat low above the southern horizon is a kind of invisible line where the zodiacal constellations can be found. This line is called the ecliptic and is also where the sun, moon, and planets move along. This is why zodiacal constellations were so significant to astrologers. Not that astronomy scientists believe in the pseudoscience of astrology, most don't, but astrologers were some of history's first astronomers, and for their early work we are in their debt. Our first zodiacal constellation is Libra, the Scales. Unfortunately, Libra is very faint, so you probably won't see it unless you're at a good dark sky site on a moonless night. But if you are, you can see its triangular top and its two balancing arms. For those of you too young to know about this ancient technology, scales were used to figure out how much things weighed by putting an item of unknown weight on one side of the scale and then adding known weights to the other side until the two sides became perfectly balanced. The known weights would then be added up to give the weight of the object. Nowadays, it's all done electronically with digital readouts. But anyways, back to our zodiacal constellations. To the left of Libra, we find the constellation of Scorpius, the Scorpion, or as astrologers call him, Scorpio. He's got two arms and claws, his bright reddish heart is Antares, and a long body with stinger. Because the Scorpion is a sign of the zodiac, and because the planets only move along the ecliptic where the zodiacal signs are found, sometimes the also reddish in color planet Mars passes near Antares. Mars represents the Greek god of war, Ares. So, to avoid confusing the two reddish stars, one is called Ares and the other is called not Ares or Antares. To the left of Scorpius is the constellation Sagittarius, the archer, with his triangular head, body, feet, left hand holding out his bow, while his right hand is held aloft, as though he just loosed an arrow. Just to the left of Sagittarius are two bright quote-unquote stars, which aren't stars at all, but rather the planets, Saturn on the left and Jupiter on the right. If you get a chance, take a look at them through a big telescope as you can. They are both rather spectacular. Just to the left of Saturn and Jupiter is our last zodiacal constellation of the night, Capricornus, the Goat. At first glance, he looks like a child's top, or an upside-down pyramid. But as you can see, he's got a horn on his head, a body with legs, and a small tail. And that's it. There are other smaller or fainter constellations out there which I encourage you to look for using a good book and a pair of binoculars too. Speaking of good books, I cannot more highly recommend the book The Stars, A New Way to See Them, by the author H.A. Rey, who you may know as the same author who wrote the Curious George books. Ray was a scientist who wasn't satisfied with the way modern star charts were drawn. The astroscientists were not interested in the characters, objects, or stories behind the constellations. So for convenience, they just connected the brighter stars into weird geometric shapes, slapped on their Greek names, many of which would mean nothing to the common person, and left it at that. That's all fine and well for them, but for us regular folk, we're more interested in the fun stuff. If you really want to learn the constellations, get Ray's book, which can be purchased from Amazon.com for about $12. I'd also recommend getting a pair of binoculars before getting a telescope. Binoculars are cheaper and easier to use, and there are many wonderful deep sky objects that can actually be best seen with just a pair of binoculars that are noted in Ray's book. If you do want to get a telescope, ask us or research on the web how to make an informed purchase. Be warned, there are a lot of bad scopes out there with cheap components and shaky, muddy, fuzzy views that will disappoint you every time. A good scope will inspire you and your children to a lifetime of deep space exploration and an appreciation of science and nature in general. If you're interested in getting into the hobby of astronomy, joining a local astronomy club can be most helpful. Chabot is partnered with EAS, the East Bay Astronomical Society, which has many activities and resources you'll find essential to helping get started in this amazing and beautiful study of our natural universe. Thanks for watching this video. If you like this content, be sure to click the thumbs up button, subscribe to our channel, and hit the bell notification icon to find out when new content has been uploaded. This will really help our channel to grow, which will make us happy. And we'll see you in the future.
All right. Well, I hope that was educational for you. There's one thing, actually a couple things that Don and Barbara covered in that video that I wanted to mention. First of all, he talked about Saturn and Jupiter. If you're around tomorrow night, we're going to have our virtual telescope program that will start at 9:30 on Chabot's Facebook page. And we will be attaching a camera to Chabot's big 36-inch telescope, the one we call Nellie. And among other things, we're going to be looking at Saturn and Jupiter. So you'll get a chance to see what they look like in the telescope. If you want to see them tonight, you can go outside. It's a fairly clear night here in the Bay Area. So you can go outside, look to the southeast around 10 o'clock or so. You'll see one very bright star and one not so bright star right next to it, to the left of it. And the bright one is Jupiter, and the a little bit less bright one next to it is the planet Saturn. So they're going to be in our sky for several weeks now. So our virtual telescope program tomorrow night will be a good chance for you to see it, or see them rather. We'll also be looking at some planetary nebula, dying stars, some globular star clusters, and some other star clusters. And I'm hoping we're going to be able to see a newly discovered asteroid, a newly discovered near-Earth asteroid. We're going to be working on that later on tonight. So if everything works out, you should be able to see it tomorrow night in our virtual telescope program, which starts at 9:30. Now, in the video that you just saw, Barbara talked about the ecliptic. And I wanted to talk a little bit more about that because I think some people are not quite sure what the ecliptic is. The ecliptic is an imaginary line in the sky. And I want you to imagine that we could turn the brightness down on the sun and watch the sun and see where it is relative to the background stars. Now, most of you hopefully know that the sun orbits the Earth. And I'm sorry, the sun doesn't orbit the Earth. No, that's about 400, 500 years ago. Today we know that the Earth orbits the sun. And so if we were to watch the sun, and if we could turn the brightness down to where we could see the stars behind it, over the course of a year, as the Earth orbited around the sun's position relative to the background stars would appear to change. And it would seem to follow a path through the sky. And if we plotted the position every night over the course of a whole year, it would appear that the sun follows a path that's a circle all the way around the Earth. Now, it's actually not the sun that's moving, it's the Earth that's moving. And as the Earth moves, our perspective of the sky behind the sun changes. And you can kind of mimic that. If you hold your finger up and move your head back and forth, you'll notice that the background behind your finger seems to change position as well. That's what's going on when the Earth orbits around the sun. So this fact that the sun appears to travel through the sky in a circle around the Earth every year has been known for thousands of years. And in fact, for a long time, people thought it was the sun that was orbiting around the Earth. And we now know, of course, that it's the Earth that's orbiting around the sun. But ancient astronomers, long before they had computers or smartphones or GPSs or even paper calendars, they wanted to be able to use the sun as a way of telling the time of the year. They knew that the sun followed the same path year after year after year. And so they figured out that if they knew in what part of the sky the sun would be at any given time of the year, they could use it as a calendar. They would know that if the sun is in one part of the sky, it would be time to plant the crops. And if it was in a different part of the sky, it would be time to harvest the crops. And yet another part of the sky, it'd be time for the snows to start falling. So they realized that they could use the sky as a kind of calendar. And by looking at that apparent path of the sun through the sky, they began to divide the sky up, taking all the stars that were along that apparent path, which we call the ecliptic, and dividing them up into groups of stars and giving names to those groups of stars and telling stories about them to go along with those names. And that was the idea of first idea for forming constellations, just groups of stars through which the sun would travel. And we call those constellations now the Zodiacal Constellations. They are the constellations through which the sun appears to move over the course of the year. And by saying, hey, the sun's going to be in Pisces at one point in the year, or it's going to be in Taurus, the bull, at another time, we could actually use the sky as a calendar. And for literally thousands of years, that's exactly how they did it. Now, of course, today we've got real calendars, and we've got our phones and our computers and all kinds of things to tell us what the dates are. But we still refer to those constellations as the Zodiacal Constellations. And of course, later on, after they named all the constellations along the ecliptic, they started grouping other stars in the sky. And pretty soon we ended up with a whole bunch of constellations. And today we have 88 official constellations in the night sky. But the ones along the ecliptic are the ones that are called the Zodiacal Constellations. Now, again, this imaginary line, the ecliptic, is the apparent path of the sun through the sky as a result of the Earth's orbit around the sun. But it turns out that the other planets in the solar system also orbit around the sun in paths that are nearly parallel to the Earth's orbit. They orbit in the same direction as the Earth does, and their orbital paths are almost parallel to the Earth's orbit. And because of that, those other planets always seem to be on or very close to the ecliptic. So not only does the ecliptic show us where the sun will be, it also shows us where the planets will be. And so when you go outside tonight, and if you look at Jupiter and Saturn, you'll see that they form kind of a line. That line is the ecliptic, and it's the imaginary line that is the path that the sun follows and also the path that the planets follow. Okay. Excuse me there for a second. So what I'd like to do now is just kind of open it up for questions. And I'm going to be watching the Facebook page to see if there are any questions that come up. If you've got any questions, just go ahead and put them in the chat section of the Facebook page. Between Jessica and I, we'll try to pick up all those questions and answer them for you. So take it away. I see that lots of people are donating. That's great. And again, I want to remind you about that auction that we have, the live auction, or the auction that we have that's going to be going on all month long. Some of those really cool moon prints is something you might be interested in. Somebody has asked, what's the best time to see the International Space Station? Well, it depends. The International Space Station orbits around the Earth every 92 minutes. And each time it orbits, it orbits over a different part of the Earth. The Earth is rotating under the orbit of the space station. One of the things that people don't realize is that the orbit of the space station is fixed in space. So if you were to take the plane of the orbit, the circle of the orbit around the Earth, if you use that to form a flat plane, perpendicular to that flat plane, that line would always point to the same spot in space. So what happens is the Earth rotates under the orbit of the space station. And as it rotates, of course, different parts of the Earth are under the space station every 92 minutes. So the space station does not appear consistently over us. It appears over different parts of the Earth at different times. So there are a couple of websites that you can go to that will tell you when to expect the space station to be over your location. The one I like to use is called heavensabove.com. It's heavens-above.com. And you go to that website, you enter your location, and it will tell you when over the next 10 days, if there are going to be any space station flyovers, and it'll tell you which direction to look and how high it'll get in the sky and how far across the sky it will move. And it's very handy, and we use it quite a bit. Okay, another question. How many constellations are there? There are 88 official constellations. Now, over the centuries, different astronomers and philosophers have rearranged the stars or rearranged the constellations. Different cultures refer to them differently. And as astronomers began to communicate with each other around the world, that became a source of confusion. So in the 1920s, an organization called the International Astronomical Union got together, and after a lot of debate, they created 88 official constellations, which are now recognized around the world. So everybody now refers to the same constellations. So there are 88 constellations in the night sky. Most of the constellations that you see in the northern hemisphere are named after characters or stories or figures in Greek philosophy. In some cases, Arab names are given to them because the ancient Babylonians and the ancient Arabs were actually very good at astronomy and mapping the sky. But the constellations in the southern hemisphere didn't get named until much later. And so you'll see some interesting names like microscopium or telescopium and things like that. So there's some interesting names for the southern constellations. whereas the northern constellations are named after Greek heroes like Hercules and Perseus and so forth. So anyway, 88 constellations is the official answer. How many constellations can we see in the summer? Well, it depends on how long you want to stay up at night. At any given point, there are a different number of constellations in the sky. The constellations are not all the same size. Some are quite small and others are quite large. So it depends on the time of night when you're looking as to how many you can see, but at least several dozen if you're in a good dark sky location. Here in the Bay Area, we've got a lot of light pollution, so you can only see the brightest constellations. So if you were to go outside right now and look up in the sky, you could probably see the constellation Boötes with a bright star called Arcturus. You could see the constellation Lyra with the bright star Vega, the constellation Cygnus the Swan. Brightest star in it is called Deneb. You could see Aquila, and its brightest star is called Altair. Those three constellations, those three stars in three different constellations, Vega, Deneb, and Altair, form what we call the summer triangle, and each star is in a different constellation. And then, of course, Hercules is up, and Corona Borealis is up. Aries comes up a little bit later on, and if you stay up late enough, you'll be able to see Pegasus and quite a few others. So it just depends on the night or the time of night. Don mentioned, or Barbara mentioned in the video, a book by H.A. Ray, which is one of several books that you can get that describe the night sky for different times of the year. So you can go to that book and look up for, say, the springtime sky, and it will show you what the spring sky looks like. It'll show you what the summer sky looks like. You can also subscribe to a couple of different magazines. There's a magazine called Sky and Telescope, another one called Astronomy magazine. And each of these has a monthly sky chart that will help you figure out what constellations are up for a given time of night. So that's kind of how you want to figure out what's up in the sky at night. Let's see. Which constellation has the most visible stars? Okay, that is the constellation Orion. Orion is a wintertime constellation. So December, January is when you will see Orion. It's a very easily identifiable constellation. It's got those three stars that form the belt of Orion, and it is the constellation that has the largest number of visible or bright stars in it. So it's one of the easiest ones to find, and it's pretty recognizable for most people. All right, well, let's see if we get any other questions coming up here. How large is the Chabot telescope in relation to other telescopes of this caliber? Well, we have 3 observatory telescopes. Our smallest telescope is an 8-inch refracting telescope. That's also our oldest telescope. We call it Leia. The next oldest telescope is Rachel, which is a 20-inch refracting telescope. Refractors are long, hollow tubes with a lens at one end and an eyepiece at the other. So both Leia and Rachel are refractors. Leia is 8 inches in diameter. Rachel is 20 inches in diameter. Our biggest telescope is Nellie. Nellie is 36 inches in diameter, so it's quite a bit larger. And it is a reflecting telescope. So instead of mirrors, instead of lenses, it uses mirrors. So it is our biggest, and it's the most powerful of our telescopes. It's the one that can see the farthest and can see the faintest. Generally speaking, the wider a telescope is, the more light it gathers, the fainter the stars it can see, the farther it can see and the more detail it can see. Contrary to popular belief, magnification is not how astronomers rate the power of telescopes. We rate the power of telescopes based on the diameter of the telescope. So when you hear professional astronomers talking about their telescopes, they will refer to them by their size, whether it's 1 meter in diameter or 4 meters or in diameter. The biggest ones in the world right now are 10 meters in diameter. That's 33 feet. So that's how professional astronomers refer to their telescopes, not by the magnification, but by the diameter, which tells them how much light and how faint an object you can see. Question, why was Chabot chosen as in its current location? The current location is the third location for Chabot. Chabot originally opened in what is now downtown Oakland. There's a small park in downtown Oakland near the federal building called Lafayette Plaza. And that was the original home of what was then called the Oakland Observatory. It was built in 1883 for the schools, Oakland schools. And it was, at that time, it was right across the street from a high school. And that's when the 8-inch telescope was built. That's Leia. And it operated from 1883 until 1915, when it moved to our second location. The second location was farther away from the city. At that time, it was well away from all the city lights. On a ridge up above what is now the intersection of Highway 13 and Interstate 580. And they moved to that site in 1915. That's also when they had the 20-inch telescope built. And it operated at that location from 1915 until the year 2000. And in the year 2000, Chabot moved to the current location. And the current location is as high and as far as you can get and still be in the city of Oakland. The Chabot Space and Science Center is what we call a joint powers agency. It's actually managed by the city of Oakland, the Oakland Unified School District, and the East Bay Regional Parks, with participation by the East Bay Astronomical Society. Because of the association with Oakland, the facility has to be in the Oakland city limits. So if you were to look at a map of the county line and the city line, you would see that the current location is right at the border of the city of Oakland and Contra Costa County. In fact, if you were to go up to Chabot and park in the parking garage is actually outside of the city of Oakland. It's in Contra Costa County, and the facility itself is in the city of Oakland. So we wanted to find a place that was high, and we wanted to find a place that was far from the city lights as we could get, and that's how we ended up being up there on Redwood Ridge. Which planets can I see in the night sky right now without binoculars or a telescope? You can easily see both Jupiter and Saturn. Again, if you look to the southeast, you'll see one pretty bright star, which is actually the planet Jupiter. And to the left of it, if you hold your hand out and hold up 2 fingers, actually about 3 fingers at arm's length, put one side of your fingers on Jupiter, you'll see on the other side is the planet Saturn. It's not as bright as Jupiter, but it is one of the brighter objects up there. So Jupiter and Saturn are easy to see. If you want to stay up for a while, around midnight or so, you'll see Mars come up. And Mars is really easy to identify. It's bright, and it's kind of got a reddish orange color to it. So it's very easy to see. Now, if you do have a pair of binoculars and you want to check out Jupiter, you might be able to see Jupiter's moons. It's got 4 bright moons that orbit around it. And with some luck, you can see those moons even in a pair of binoculars. Can we still see the Perseid meteor shower tonight? You might. The Perseid meteor shower actually lasts for a couple of weeks. It peaks around the 12th of August, but that's just when we go through the densest part of the meteor stream. But there are sporadic ones that come along before and after. No, I shouldn't use the word sporadic. That's a different type of meteor. It's just fewer meteors from the Perseid stream before and after the 12th. So if you were to go out tonight, and if you were find yourself a dark location, sit back and stare at the sky for a while, you might get a chance to see one or two of the Perseids from that weren't part of the main stream that was on the 12th. What is the brightest visible star in comparison to its size? How big is it? Well, let's see. Different ways of answering that. One of the biggest stars that you can see with your naked eye right now is Antares, which is in the constellation Scorpius. Antares is kind of an orangish yellow star. It's low in the southern sky, so it might be a little hard to see from here in the Bay Area because of all the city lights. But if you're out away from the Bay Area, away from the city lights a little bit, and you look to the south, you might see this kind of a yellowish orange star in the constellation Scorpius. That's Antares. Antares is a giant star. It's probably close to 700 or 800 times the diameter of the sun. If you want to hang around to wintertime, the star Betelgeuse in the constellation Orion is nearly 1,000 times the diameter of the sun. It's a supergiant, red supergiant, and it's approaching the end of its life. We think sometime in the next 100,000 years or so, it's going to explode as a supernova. So it has grown quite large, which is common for stars. Once stars get old, they swell up and become very large. If you want to hang around for 5 or 6 billion years, you'll see our sun grow to be more than 100 times its current size. But Betelgeuse is a much more massive star. And right now, its diameter is about 1,000 times the diameter of the sun. Okay. What is the Kuiper belt? Oh, good question. You asked the right person. When I got my master's degree, I did my thesis on the Kuiper belt. So the Kuiper belt is a region of the solar system out beyond Neptune. And in this region, there's kind of the leftovers from the formation of the solar system. And these are mostly icy bodies, can be anywhere from a few meters to a couple of hundred meters or more, or a couple of hundred kilometers or more in size. And these objects orbit around the sun at a very great distance, more than 50 times, or some of them are more than 50 times farther from the Earth, or from the sun, than the Earth is. So we call the average distance between the Earth and the sun an astronomical unit. And the Kuiper belt is somewhere between roughly 30 and 100 astronomical units away from the sun. And these are all icy bodies that orbit around the sun. There's actually quite a few of them out there. There's literally probably 1 million of them out there. But because they're so far away, there's a lot of space in between them. So even though there's a lot of icy bodies out there, they don't bump into each other very often. And once in a while, if they do bump into each other, or if a star passes by and gets a little close to us, one of those icy bodies may get dislodged from the Kuiper belt and work its way in towards the inner solar system, and we would see it as a comet. Now, most comets come from even farther out in a region called the Oort Cloud. the difference between the Oort Cloud and the Kuiper Belt. The Kuiper Belt you can think of as sort of a torus or like a donut around the sun. So all of the objects in the Kuiper Belt orbit in the same direction as the Earth orbits around the sun, and they orbit close to the ecliptic, but not necessarily on the ecliptic. They're much more scattered, so they can be higher or lower than the ecliptic by quite a bit, but they still orbit in the same direction and stay close to the ecliptic. The Oort Cloud is different. Objects in the Oort Cloud, which are very far away, 1,000 astronomical units or more, those objects can orbit in any direction. And there's quite a few of them out there. And a lot of the comets like Neowise that we saw a few weeks ago that have very long orbital periods, they come from the Oort Cloud. Okay, when will the Voyager probes reach a star, and what star will it be? Well, it's going to be a long time before any of them reach a star, and I don't know off the top of my head which star they will reach. It's going to take them so long to get away from the sun far enough to where they actually get close to another star that the stars will actually have changed position by the time they get there. So I can't tell you off the top of my head. It's something maybe I can look up, and next time we talk, I can answer that question. But off the top of my head, I don't know what star they will approach. But the two spacecraft are going to take a very long time to get far enough away from the sun to where they will start getting in the vicinity of other stars. They both have reached a region we call the heliopause. As some of you may know, the sun produces a solar wind that blows outward, blows ionized particles outward from the sun. That wind blows outward quite a ways from the sun. But the sun itself is orbiting around the galaxy, and as it orbits the galaxy, it passes through clouds of gas and dust. And there is a point, certain distance away from the sun, where the pressure of us passing through those clouds of gas and dust equals the pressure of the solar wind blowing outward. We call that the heliopause. And right now, this Voyager spacecraft are in the vicinity of the heliopause, which is several billion miles away from the sun. Okay, well, I think we've run out of questions here. It's almost 9 o'clock. So unless I see any more questions here, I think it'll be time for us to sign off. Again, I want to remind you about our virtual telescope program tomorrow night at 9:30 Pacific time, and Ben Barres's program on the history of Chabot next Wednesday. And then, of course, our anniversary program a week from tonight at 8 o'clock. You want to check that out. Lots of cool stuff, stories about the old Chabot sites and our new Chabot sites, and lots of cool activities. So check that out a week from tonight. And I will see those of you who decide to watch the virtual program. I will see you tomorrow night. Everybody have a good evening. And for those of you in the Bay Area, stay cool.